Next is question number 71, which says that if y equal to mx plus c is common tangent to the circle x square plus y square equal to 4 and the parabola x square equal to minus 4y, then the positive value of greatest integer of m square is. Now the equation of tangent on the parabola will be tx equal to minus y plus t square, right? Now if this is a tangent on the circle, put the value of y as t square minus tx. So we will get that x square plus t square minus tx whole square is equal to 4. Now as it is a tangent on the circle also, so the discriminant will be equal to 0. That is x square plus t raised to the power 4 plus t square x square minus 2t cube x minus 4 is equal to 0. That is, it can be rewritten as x square into 1 plus t square plus x into minus 2t cube plus t raised to the power 4 minus 4 is equal to 0. So from here we get that discriminant is equal to 0. That is 4 into t raised to the power 6 minus 4 into 1 plus t square into t4 minus 4 is equal to 0. Cancelling 4, we will get t6 minus t4 minus 4 plus t6 minus 4 t square is equal to 0. Cancelling these two terms, we will get t raised to the power 4 minus 4t square minus 4 is equal to 0. So we say that t square is equal to 4 plus minus under root 16 plus 16 upon 2. That is t square is equal to 2 plus minus under root 32 upon 4, that is under root 8, that is 2 root 2. Now as t square is a positive term, so this will be equal to 2 plus 2 root 2. Now we have to find the value of m square. Now we know that t is equal to minus m, so we can say that m square is also equal to 2 plus 2 root 2. Now the greatest integer of m square will be equal to 4. That is, the correct answer is option number 2. Next is question number 72, which says that the length of the common chord of the circles x square plus y square plus 2gx equal to 0 and x square plus y square plus 2fy equal to 0 if g square plus f square is not equal to 0 is. This means that neither g nor f are equal to 0. Now we have to find the common chord of the circles. Let us say these are the two circles and this is the common chord AB, and let us say the centers are P and Q. Now the center, that is P, will be equal to minus G comma 0 and Q will be 0 comma minus F, and its radius will be equal to mod of G. Similarly, its radius will be mod of F, right? Let us find the equation of AB first. That will be equal to S1 minus S2 equal to 0. That will give me 2gx minus 2fy equal to 0. That is, the equation is gx minus fy equal to 0. Now the equation of AB is known and we know the coordinates of point P. So let us drop perpendicular from P on AB. That, let us say this point is M. So PM will be equal to minus g square mod upon under root of g square plus f square, right? So this is equal to g square upon under root of g square plus f square. We know the length PM, we know BP. So from here we can find BM square. That will be equal to g square minus PM square. That will be equal to g raised to the power 4 upon g square plus f square. So this will be equal to g square f square upon, in the denominator we have g square plus f square. So from here we can find the length of BM will be equal to modulus of GF upon under root of g square plus f square. That is, we can see that the length of the common chord, that is AB, will be equal to 2 times BM. That will be equal to 2 into mod of gf upon under root of g square plus f square. That is, the correct answer is option number 2. Next is question number 73, which says that the minimum distance between vertices of the parabolas xy equal to 1 and xy equal to 4 is. Let us say this is the coordinate axis, x and y. So, the graph of xy equal to 1 will be something like this, and the graph of xy equal to 4 will be something like this. Now, let us say this is the line passing through the vertices of the hyperbola. Let us say this point is A and this is B and this is P and this is Q. Now the line is y equal to x. So for the hyperbola xy equal to 1, we can say that the point A will be equal to, putting y equal to x, we will get x square equal to 1. That is, the coordinate A will be 1, 1. Similarly, finding the coordinate B, that is x square equal to 4, that will give me 2, 2. Now, the minimum distance between vertices, that will be AB, right? So, AB will be equal to, by distance formula, under root of 2 minus 1 whole square, that is 1, plus 2 minus 1 whole square, that is again 1. So, this is equal to under root 2 units. That is, correct answer is option number 2. Next is question number 74, which says that if the hyperbola x square upon a square minus y square upon b square equal to 1 and y square upon a square minus x square upon b square equal to 1 have exactly 4 common tangents, then values of a and b can be. Right. Now, for this hyperbola, we know the equation of tangent is, let us say the slope of tangent is m. So, this will be equal to y equal to mx plus minus under root a square m square minus b square. And for the second hyperbola, we know that the equation of tangent will be y equal to, as the slope of both will be same, so the slope of this tangent will also be m. So this is equal to mx plus minus under root of a square minus b square m square. Now, as the equation 1 and 2 both signify the same tangent, so we will say that the coefficients will be in proportion. So we will say that 1 is equal to under root of a square m square minus b square upon under root of a square minus b square m square. So from here we find that m square is equal to 1, that is m is equal to plus minus 1. So putting the value in equation 1, we will get y equal to plus minus x plus minus under root of a square minus b square. Now, to have exactly 4 common tangents, we can see that the quantity inside the under root should be greater than 0. That is, we can say that a square minus b square should be greater than 0. That is, a should be greater than b. That is, the value of a and b can be a equal to 2, b equal to 1. That is given in option number 2. Next is question number 75, which says that if a, b and c vector are non-coplanar unit vectors and a vector dot b vector is lambda 1, b dot c is lambda 2 and c dot a is lambda 3, then one of the values of scalar triple product ABC is, now we know that if I square scalar triple product, so this can be written equal to determinant of a dot a dot b, a dot c, b dot a, b dot b, b dot c, and c dot a, c dot b, and c dot c. Now, this determinant can be written equal to, we know that a dot a vector is equal to modulus of a vector whole square, that is 1, and a dot b is given to be equal to lambda 1. Similarly, the values are given, this will be 1 and this will be lambda 2, this will again be lambda 2 and this will be 1. Now this will be equal to, evaluating the determinant, it will be equal to 1 into 1 minus lambda 2 whole square plus lambda 1 into lambda 2 lambda 3 minus lambda 1 plus lambda 3 into lambda 1 lambda 2 minus lambda 3. So we can say that this is equal to 1 minus lambda 2 square plus lambda 1 lambda 2 lambda 3 minus lambda 1 whole square plus again we have lambda 1 lambda 2 lambda 3, so we have 2 times this, and here we will have minus of lambda 3 square. So the value of A, B, C will be equal to under root of this, right? So option number 4 is the correct answer.